this video is about angles inside quadrilaterals, or interior angles of quadrilaterals. So let's take a quick look then at some popular quadrilaterals, some very common ones like the rectangle and the square. As you know, the rectangle and the square both have four right angles, four 90-degree angles. All of these are 90, and so that means these four angles are going to add up to 360 degrees. How did I do that? I just used my times table knowledge of the 9 times table. I did 90 times 4, and that's 36, but of course it was 90. Yep, there we go. And it's the same for the rectangle. Okay. Now, I'd like to try and convince you that all these other quadrilaterals, all these other four-sided shapes, also have an interior angle sum of 360. And in fact, any four-sided shape will have an interior angle sum of 360 degrees. Okay, now I'm going to try and convince you, right? Well, if you remember back to when you learned that triangles had an interior angle sum of 180, then you can see, for example, in this kite, there's a triangle at the top with three angles, 1, 2, 3, and those three angles add up to 180, and there's a triangle in the at the bottom with three angles, and they add up to 180 as well. And altogether, when you do 180 plus 180, you get 360. So in that case, what we could say is that this kite has an interior angle sum of 360 degrees. So now I've got to try and convince you that this quadrilateral can be broken up into two triangles. Okay, my drawing wasn't very good there, but you can kind of see that there are two triangles, and they each have an interior angle sum of 180. We can do the same here, we can do the same here, we can do the same here as well. So 180, 180, 180, 180. That's inside the triangles that we've split these quadrilaterals into. But then if we look at what the angle sum would be, it would be 360 degrees. 360 degrees for all of these quadrilaterals, or any quadrilateral. Okay, that's useful. Let's see if we can apply it to one or two angle problems. Here is an irregular quadrilateral, and now that we know that they all add up to 360, we could find a missing angle. Let's say we didn't know this one, but we did know this was 110 degrees, this was 70 degrees, and this was 95 degrees. How are we going to find the missing one? We can simply find it by adding the three angles that we do know. Da -da, da -da, da -da. 275, so the three angles that we do know add up to 275, and then the last angle is going to have to make it up to 360. So we could count upwards until we get to 360 and work out what that missing angle would be. A quicker way to do it will be to do a subtraction and do 360 take away 275. 5, 2, 15, 8, 0, 85 degrees. So this angle here is 85 degrees. And we can check that that works by seeing whether they all add together to make 360, and they do. Here are a couple of special quadrilaterals with a couple of properties that you should know to help you work out missing angles. This is a rhombus, and this is a parallelogram. Anyway, the bit that you need to know is that diagonally opposite angles, so that's angles that are opposite each other in opposite diagonal corners, so these two and these two, they're pairs of equal angles. So these two yellow angles, as it were, they're equal. The two green ones are equal. And it's the same with the parallelogram. Diagonally opposite angles are equal. So how does that help you? Well, if you know that this is, I don't know, 110 degrees, then you will also know that this is 110 degrees. The whole thing adds up to 360. These two angles, one of the yellow ones and one of the green ones, they're going to add up to 180. And so in that case, this one over here must be 70. Because 70 and 110 together make 180. Okay, special properties here. This is an isosceles trapezium, and the angles at the top are equal, and the angles at the bottom are equal. So if you know this one down, either of the bottom two angles, for example, if this was 80, you would know that this is also 80. And the white and the yellow angles, they're going to add up to 180, so that means the white one at the top is 100 degrees, and it has to match this one as well, so that's 100 degrees too. And finally, the kite or the arrowhead. In the kite or the arrowhead, these two angles are equal. Those two angles are equal in the arrowhead. However, this angle at the top is different to the angle at the bottom. Okay, and this angle up here is clearly different to this reflex angle here. Okay, so that would help you in the sense that if you find out that this is 140 degrees, then this has to be 140 degrees as well. Okay, that's the end of the video. Thanks very much for watching. Bye.